Question number 3 of exercise 6.2. It is like that. Show that the function given by fx equal to sin x is a strictly increasing in open interval 0 to 90, b strictly decreasing in 90 to pi within the open interval, and question number c is neither increasing nor decreasing in 0 to 180. It is also in open interval. Now we have to show function is our fx equal to sin x and strictly increasing, and by using the application of derivative. So before that, we have to remind our theorem is what? That first derivative, that is f dash x, if it is positive for some interval, then it is increasing, and strictly increasing if it is in the open interval. If first derivative is negative, then it is decreasing, and if it is what in the open interval, then it is strictly decreasing. And if we found it is neither positive nor negative in an interval, then we can say it is neither increasing nor decreasing. So we have to take this theorem. Here fx is equal to sin x. Therefore, first derivative, that is f dash x, is equal to d dx fx. That is differentiation of sin x. Which is what? Differentiation of sin x, we know it is cos x. Then in 0 to 90 open interval, cos x always gives a positive value. That is, f dash x is positive. Therefore, fx is strictly increasing in open interval 0 to 90. Now, if we consider that interval 90 to 180, see, it is the second quadrant, and cos x always gives negative value in this. In second quadrant, that is, if we consider this our quadrant, then first quadrant all positive we know, second quadrant sine and cosec positive, and all sine, then it tan positive, tan or cot positive, and then last one cos or sec positive. So sine positive here, sine and cosec, so cos is negative, cos and others are negative. Therefore, that is f dash x, cos x is our f dash x, so f dash x is negative. Therefore, fx is strictly decreasing in 90 to 180. Now, in 0 to 100, if we consider, cos x is partly positive and partly negative. Therefore, f dash x is neither positive nor negative. Therefore, fx is neither increasing nor decreasing in 0 to 180. So this is our first this question what it was, that a function it is given by fx equal to sin x is strictly increasing in this, strictly decreasing in this, and neither increasing nor decreasing this one. Here we are applying the rules of derivative. Rules of derivative is what, that if our first derivative is positive in some interval, then it is strictly increasing. If it is negative in some interval, it is strictly decreasing. If it is sometimes positives, one part positive, one part negative, because 0 to 90 you find 0 to 90 it is positive, 90 to 180 negative. That means within 0 to 180 it is partly positive and partly negative. So it is neither positive nor negative in whole interval. Therefore fx is neither increasing nor decreasing in 0 to 180. Now we will go for next question. That they said, find the interval in which the function f is given by fx equal to 2x square minus thrice x is strictly increasing, strictly decreasing. That again similar type of questions like previous we have to do. So here also we will do what? Here given fx equal to 2x square minus thrice x, therefore f dash x, that is differentiation of fx with respect to x, is equal to d dx of 2x square minus thrice x, because we have to differentiate this one fx to this value. Now if we differentiate 2x square, it is 2 differentiation of x square with respect to x minus differentiation of x with respect to x. Differentiation of x square with respect to x is twice x. Twice x into 2, it is 4x. Differentiation of x with respect to x is 1, so it is 3 into 1 is 3. Now, if f dash x is 0, it is our procedure of finding that we will find that what will be the interval. So definitely we have to find that what interval that is, it is f dash x is positive or negative. For that only we have to find first that f dash x is 0 for what? That is f4x minus 3 is equal to 0 implies x is equal to 3 by 4. Definitely 3 if we take this way and divide by 4, this one. So we get two intervals. One is in the real number, if you see it is 0, it is 1. So here somewhere it is 3 by 4 is here. So it is minus 1, then it is 2, there minus 2, it is the real number. So we will get before that one interval, and after 3 by 4 this one another interval. So this interval, that is minus infinity to 3 by 4 open interval, and 3 by 4 to infinity, this is the second interval. So we are getting two intervals. Now we have to check for that interval what is the value of our f dash x. For this interval minus infinity to 3 by 4, if we put any value, suppose minus 3 by 4 less than this one, suppose 0. If we put 0 in our f dash x here, you will get what? Minus 3. Or if we put any value, suppose minus 1, then it will give always minus 1. So here f dash 0, it is what? 4 into 0 minus 3, it is negative term. F dash minus 1, if we put 4 into minus 1 minus 3, so what we get? Minus 7. So always gives f dash x for this interval is negative. We will check by putting these values. So f dash x here for this interval is negative. So f dash x, if it is negative, what we can say? Therefore fx is strictly decreasing in this interval minus infinity to 3 by 4. Now for 3 by 4 to infinity. Now 3 by 4 to infinity, you see, for this interval if we check, suppose f dash 1, f dash x is this, so if we put 4 into 1 minus 3, 4 minus 3 is the 1, it is the greater than 0. We will check for another value, f dash 2, 4 into 2 minus 3. So in this interval we are checking by this way. So here you see that 5, it is also positive. If we put any values greater than 3 by 4, this gives what? A positive value. So we will write f dash x is greater than 0. Therefore, what we can say, as f dash x is greater than 0, so f dash x less than 0, it is the strictly decreasing. So here it will be fx is strictly increasing in 3 by 4 to infinity. So they have asked to find the interval in which the function given by this is strictly increasing, strictly decreasing. So we have done first derivative, then we have calculated this one, that f dash x is 0 for what values of x. Then we have calculated the two intervals. Then in first interval we have checked by this trial error method. We found all the values of this interval gives the f dash x as negative value. So as it gives negative value, so definitely fx is strictly decreasing in this open interval. For open interval 3 by 4 to infinity, we found f dash x gives all positive values. By checking this one, we are confirmed that yes, it is giving this one a positive values. Therefore, we can say it is strictly increasing on this interval. So we get to two interval, minus infinity to 3 by 4 open interval, and 3 by 4 to infinity another open interval. This interval fx is strictly decreasing, and this interval this is strictly increasing. So this is the